Hello friends, welcome to the session, continuation of chapter 7 DC to DC converters. Okay, I started a steady state analysis of type A chopper. That concept I am continuing. In the last session I discussed about what is the duty cycle at boundary condition. That means the minimum value of duty cycle for which current is just continuous. That I given this continuation of steady state analysis of type A chopper, that you concentrate. Okay, what the minimum duty cycle at which current is just continuous, d dash equal to this formula I given, Ta by T into ln of 1 plus m into e power T by Ta minus 1. This formula you know. This is the minimum duty cycle at which current is just continuous. Okay, what is m here? Is m equal to E by Vs. E by Vs, where E is the battery voltage, Vs is the supply voltage. You take Vs or VDC. Okay, and I given, if it is given duty cycle is, if given duty cycle is D, if given duty cycle is D, then based on this, if D greater than D dash, then it is which mode? Continuous mode. If D less than D dash, it is discontinuous mode. If D equal to D dash, this is just continuous. Just continuous. This is at boundary. These observations I given in the last session. Okay. Now I want to give some more observations based on this concept, that you concentrate. See, for example, if Ta by T equal to 1 and take m equal to 0.5 or to D equal to 0.5. If Ta by T equal to 1 or m equal to 0.5, let us assume that at m equal to 0.5, then you calculate what is D dash. D dash equal Ta by T is 1 is I taken, 1 plus m is 0.5 I taken, e power 1 minus 1. This we get D dash is nearly equal to 0.62 something you can get. Approximately I am giving. D dash equal to 0.62 you can get. Okay. Now with this observation, if you draw the character 6, let here I am explaining this concept with which is the continuous mode of region and which is the discontinuous mode of region. This I am explaining the concept. Okay, let in this axis I taken D dash and in this axis I taken D. Duty is a given duty cycle, and this is the calculated duty cycle, that is at a just continuous. Let this is 0, 0.25, 0.5, 0.75 and this is 1. Same 0.25, this is 0.5, 0.75 and this is 1. Then if you draw if TA equal to T, let this is O, let this is B, and this is C, and this is D, because I want to tell reason of operation. Okay. Then if you take TA by TA equal to 0, then TA by T equal to 0 you take. If TA by T equal to 0, then we can get the curve like this. This is D dash equal to 0. This is D dash equal to 0. D dash is 0, this one. Then we can get this is the curve, straight line curve for TA by T equal to 0. But practical it is not possible. This is ideal case, I am drawing this one. This is the curve for TA by T equal to 0. For TA by T equal to 0. This curve I am drawing for TA by T equal to 0. Okay. Then above this, there is no operation of chopper. The reason I will tell. This is no operation. No operation of chopper. Then if you draw the curve for TA by T equal to 1, M equal to 0.5, then we are getting the characteristics like this. Let this is A. Let this is A. This is OAB. This is the curve for TA by T equal to 1. Then similarly, if you take the curve for TA by T equal to 5, for different values of TA by T I taken, I am drawing the curve. Then this is for TA by T equal to 5. That means the curve OAB and OBC, a point to remember, for TA by T equal to 1, curve, or for TA by T greater than 1, or TA by T greater than 1, curve OAB and OBC. This curve OAB and OBC gives continuous mode. This region gives the OAB region and OBC region gives the continuous mode. But OB never be possible. Curve OB never be possible because TA by T equal 0 means meaningless. Curve OB never possible and TA by T less than 1 is also not possible. TA by T less than 1 is also not possible. That's why this operation is not possible in the chopper. Why I am telling that TA by T less than 1 not possible? TA is nothing but a L by R. Okay. This is switching frequency 1 by F. Frequency you can get in kilohertz. You are operating at a very high frequency. That's why TA by T less than 1 is not possible. This is the area for TA by T less than 1. TA by T less than 1 is not possible. That's why this operation is not possible. That's why OB curve is not possible. Okay. That's why this is no chopper operation and this is the chopper operation. This is for chopper operation. That means for TA by 2, for 0 less than TA by T less than 1. For 0 less than TA by T less than 1. Then no operation. For less than 1 is not possible, no operation. No operation of chopper. No operation of chopper. Okay. Then one more point to remember. For TA by T equal to 5, curve OBC represent, this curve OBC represent continuous mode. Curve OBC represent, this area will represent the continuous mode. For TA by T equal to 5, for TA by T equal to 5, then it is continuous mode. Curve OBC is, this OBC curve is operated in continuous mode. OBC curve is operated in continuous mode. For TA by T equal to curve OBC is operated in continuous mode. Okay, but for 0 less than TA by T less than 1, no operation of chopper. Okay, like this we can identify which is continuous mode and which is the discontinuous mode, which is no operation. This OAB represent or OBC represent continuous mode. If you take, this is for TA by T equal to 1, in between these two, then it is operated in discontinuous mode. For TA by T equal to 1, for TA by, this is TA by 2, 0, and this is TA by 2 greater than 0. Less than 0 is not possible and less than 1 is not possible. That's the reason why you take, this is curve OAB and this curve OBC represent which mode? Continuous mode. Okay, note down this quick. Even curve OB is not possible, curve OBD is also not possible. For 0 less than TA by, no operation of chopper means OB and OBD is not possible. OB and curve OB and OBD is not possible. OBD is not possible. This curve OAB and OABC, this is not OBC, you take OABC is continuous. For TA by T equal to 5, we are getting OBC is continuous mode. This curve OBC is continuous mode. Then what about OAB? For TA by T equal to 5, curve OAB becomes, this is a discontinuous mode. Curve OAB becomes discontinuous. But this is curve OAB, OBC becomes continuous mode. If it is for TA by T equal to 5. Okay, different values we can substitute here, then we get idea then what is the continuous mode, when it is continuous mode and when it is discontinuous mode. That is enough. Okay, but here just to concentrate which is not operation, which is operation. Below this chopper operation is possible. Below this chopper operation is possible. Above this it not possible. Clear? Okay. This about how to analyze a continuous or discontinuous mode in a type A chopper with respect to RLE load. But this I want to extend this concept to derive the two formulas. I want to write the under constant current supply, what is the average current through the thyristor or switch. Here switch is nothing but let's assume that thyristor. Then what is the condition for maximum average thyristor current? That means what is the duty cycle at maximum average thyristor current? What is that value? Similarly, I want to explain what is the freewheeling diode current, what is the duty cycle at maximum value of RMS freewheeling diode current, and what is that maximum RMS value of freewheeling diode current. That two concepts I want to discuss. Okay. First you start with the first one is average switch current or average thyristor current. Average value of the switch current. Switch is nothing but a thyristor or thyristor current. thyristor current in type A chopper. Type A chopper with RLE load. Average value of switch or thyristor current in type A chopper. Here this formula I am giving with the assumption of constant current. Let assume that a constant current is supplied to the load. Let I naught is constant. The average load current is constant. If it is constant, then what is IT average? IT average is equal to, during which time thyristor will conduct on time? T on by T. Average value of switch or thyristor. I naught into T on by T. Then how to write D I naught? T on by T is nothing but a T, that is D I naught. This is average value of this. This also write like this, D into, how to write I naught? Let it is a constant current, RLE load, V naught minus E by R. Then how to write V naught? That is D into dVs minus E by R. This is exact formula. This is average value of switch or thyristor current. Then what is the duty cycle at maximum average thyristor current? Yeah. To get the condition for maximum average thyristor current. Condition for maximum average thyristor current. Maximum average thyristor current. Maximum average thyristor current. How we can get the condition, you tell me? The condition for maximum average thyristor current is D IT average by DD is equal to 0. Differentiate with respect to duty cycle and equate to 0. Then what you can get differentiation? D by DD of, what you get this, D square Vs minus dE by R is equal to 0. Then 2D Vs minus E by R is equal to 0. Then from this what we can get, duty cycle equal to E by 2 Vs. This is the duty cycle at maximum average thyristor current. At maximum average thyristor current. At maximum average thyristor current. Okay. But you want what is the maximum value of average thyristor current? Then how to get maximum value of average thyristor current? The maximum value of average thyristor current means substitute this condition here. Then what you get? E by 2 Vs into E by 2 Vs into Vs minus E by R. Then get negative sign, no need to consider that. Then maximum value of average thyristor current equal to E square by 4 Vs into R. This is the maximum value of average thyristor current in a type A chopper. E square by 4 Vs by R. This is Vs cancel, E by 2 minus E. E by 2 you can get E by 2, E square 4 Vs by R, maximum average thyristor current. That means in a type A chopper, what is the duty cycle at maximum value of average thyristor current and what is the value of maximum? These two you remember. This one concept. RMS value of freewheeling diode current. RMS value of freewheeling diode current. Freewheeling diode current in type A chopper. In type A chopper. How to calculate RMS value of freewheeling diode current in a type A chopper? We know that in a type A chopper, assume that what is the freewheeling RMS value of, we are assuming that constant current. We are assuming that constant current. If you assume that constant current ripple free, then ripple free constant current means what is the RMS value of freewheeling diode current? The RMS value of freewheeling diode current, IFDR equal to I naught into square root of, during which time it is conducting off time, by T. Then what you get? I naught into square root of 1 minus T. Okay. Then shall you write like this? The RMS value of freewheeling diode current IFDR equal to, how to write I naught is written as, that is V naught minus E by R, because it is a RLE load, square root of 1 minus T. Then you simplify this one, RMS value of freewheeling diode current equal to, then how to write V naught is dVs minus E by R into square root of 1 minus T. Then RMS value of freewheeling diode current equal to D into square root of 1 minus D into Vs minus square root of 1 minus D into E by R. This is the RMS value of freewheeling diode current. Then you want to find condition for maximum RMS value of freewheeling diode. Condition for maximum value of maximum RMS value of freewheeling diode current. RMS value of freewheeling diode current. Then how to get? Differentiate freewheeling diode current with respect to duty cycle and equate to 0. Then if you do this one, you try this, you differentiate with respect to duty cycle and equate to 0, check your mathematical knowledge. Then we can get D equal to, yes, this we get duty cycle D equal to E plus 2 by Vs. This is the duty cycle at maximum value of freewheeling diode current. Note down. What is the duty cycle at maximum value of freewheeling diode current? This is 1 by 3. D equal to, by simplifying this, 1 by 3 into 2 E plus 2 by Vs. Sorry, correct this one. 2 plus E by Vs. This exact formula. The maximum value of freewheeling diode current, the condition for maximum value of freewheeling diode current equal to 1 by 3 into 2 plus E by Vs. But you want to find what is the maximum value of freewheeling diode current now? Substitute this duty cycle in this. Then the maximum value of freewheeling diode current equal to RMS value of freewheeling diode. The maximum RMS freewheeling diode equal to, we get by simplifying this one, 0.3849 into, this you write 0.3849 into 1 minus E by Vs whole to the power of 3 by 2. This is the maximum RMS freewheeling diode current. You substitute this value here and check your mathematical knowledge. Then you can get maximum RMS freewheeling diode current equal to 0.3849 into 1 minus E by Vs into 3 by 2. This into Vs by R. Okay, this exact form. Or if you want write means like this you write. Sorry, 0.3849 into Vs by R into 1 minus E by Vs into 3 by 2. E by Vs into 3. This is maximum value of RMS freewheeling diode. How we can get means substitute this condition. Direct formulas we can, based on this direct problems also we can expect. A type A chopper supplying the constant current to the load. What is the duty cycle at maximum? What is the duty cycle at maximum average series current? E by 2s. What is the value of maximum average series current? Similarly, a type A chopper is supplying the constant current to the load. What is the duty cycle at maximum RMS value of freewheeling diode current? 1 by 3 into 2 plus E by Vs. What is that RMS value of current? Maximum RMS freewheeling diode current. 0.3849 into Vs by R into 1 minus E by Vs into 3 by 2. Okay, now this concept. Quick, note down. Now you see, in continuous mode, whatever the output voltage we are getting in type A chopper, it's not a pure DC, it is a pulsating DC. Okay, that is I'm talking about in continuous mode. Now, if it is a pulsating DC, now I want to apply the what is the Fourier analysis for type A chopper. Okay, then you concentrate on Fourier analysis of type A chopper in continuous mode. I'm talking about in continuous mode. Fourier analysis of type A chopper. Fourier analysis of type A chopper in continuous mode. This is in continuous mode. In continuous mode of operation. Yes. Listen this. I given already output voltage waveform in the case of continuous mode. In continuous mode, we are getting the wave shape like this. Output voltage waveform. This is Vs. V0 is Vs. This is during which time? On time. This is during off time. This is dt. This is t. This is again on time. Then whatever this pulsating DC we are applying, then if you apply Fourier analysis, according to Fourier analysis, V0 equal to A0 plus summation n equal to 1 to infinity an cos n omega t plus summation n equal to 1 to infinity bn sin n omega t. Okay, then in this you calculate what is A0, An and Bn. Then this A0 equal to, we get V0, this is equal to dVs. What is An is? An is 0 for all values of n. For all values of n. This Bn equal to 2Vs by n pi sin n pi d. Or I'm writing instead of this directly, I'm writing this one sin n pi d. Yeah, you take Bn equal to 2Vs by n pi sin n pi d. Sorry, you do this one directly instead of this. Directly I'm writing, no need of this derivation. Okay, the instantaneous value of output voltage V0 equal to, I'm getting this is dVs summation n equal to 1 to infinity, this will become 0, then 2Vs by n pi sin n pi d into sin n omega t plus theta. Okay, this is the value of instantaneous output voltage in the case of type A chopper. What is theta here? Tan inverse cos 2 pi n alpha by sin 2 pi n alpha. This cos 2 pi n alpha by sin 2 pi n alpha. This we can get. This is the value of theta. Based on derivations we can get this, no need. This is theta equal to tan inverse cos 2 pi n alpha by sin 2 pi n alpha. This is V0. dVs is V0. This is by applying Fourier analysis. For applying Fourier analysis for this waveform, we are getting this one. Note down. Yes. This is cos, not 2 pi, cos pi n alpha by sin pi n alpha. Correct this. Then from this you write any formula. Can you tell what is the maximum value of nth harmonic output voltage? Okay, maximum value of nth harmonic output voltage. Maximum value of nth harmonic output voltage. Nth harmonic output. Maximum value of nth harmonic output voltage equal to what you can get. Without function, this term is the maximum value of nth harmonic output voltage. How much you get? 2 Vs by n pi into sin n pi d. Next. What is the RMS value of nth harmonic output voltage? RMS value of nth harmonic output. Nth harmonic output. What do you get? By root 2. Maximum value by root 2. Then what do you get? Root 2 Vs by n pi sin n pi d. All these formulas important. What is the RMS value of fundamental? RMS value of fundamental. Then RMS value of fundamental equal to RMS value of fundamental is equal to, this is V01 you take n equal to 1. Root 2 Vs by pi into sin pi d. N equal to 1 you substitute. This RMS value of fundamental. Now, that means output consists of harmonics. Na? The output voltage of type A chopper is consist of harmonics. Now the question is, this is nth harmonic output voltage. Maximum value of nth harmonic output voltage. This is nth harmonic output. To eliminate nth order harmonic. To eliminate nth order harmonic. Nth order harmonic. How we can eliminate nth order harmonic? Then which term we can equate 0? Sin n pi by, in this total, if you want to make this nth harmonic is 0, sin n pi d equal to 0. Sin n pi d equal to 0. Sin n pi d 0 means n pi d equal to pi. Then what is d equal to 1 by n? Important. What is the duty cycle you maintain to eliminate nth order harmonic? For example, to eliminate fifth order harmonic. For example, to eliminate fifth order harmonic. For example, to eliminate fifth order harmonic. Fifth order harmonic. Then what the duty cycle equal to? Duty cycle equal to 1 by 5. Like this we calculate. Like this, what is the Fourier analysis of type A chopper? Then how to write the nth order harmonic current? Nth order harmonic In equal to Vn by Zn. If it is RL load, what is Zn equal to square root of R square plus n omega L whole square. In equal to Vn by Zn. Okay. Then what is Vn? That is 2 Vs by n pi sin n pi d. Okay. Then shall you write like this? For example, if R equal to 0, then what is In is proportional to, you tell me? If R is 0, the square root cancel, we can get 1 by n. Then what is Vn? 2 Vs by n. Then In is proportional to Vs by n square. How the nth order harmonic depends on the harmonic component. Vs by n square. Okay. This point theorem. This formula is very important. 5 star. Then to eliminate nth order harmonic, what is the duty cycle? To eliminate nth order harmonic, duty cycle equal to dash 1 by n. For example, to eliminate fifth order harmonic, duty cycle. To eliminate seventh order harmonic, what is the duty cycle? 1 by 7. Like that you can write. This I am writing Vn by Zn. If R equal to 0, this denominator we can get n. Okay. But Vn you write 4 Vs, 2 Vs by n pi na. In denominator again n. N into n, n square. That is Vs by n square. Quick. Not all. Okay. This is the Fourier. Once you know all these, then you can solve. You write any formula. Can you write what is the RMS value of this R? That is RMS value of nth order harmonic is this one. RMS value of fundamental is how much? Root 2 Vs by pi into sin pi d. Okay, this you write. That means this output consists of harmonics. or it is also consist of ripples. Okay, this is whatever the AC component present in the DC output, then it is taken, generally it is also taken as a ripples also. Okay, over. Okay, this is about in detail analysis of type A chopper. Okay, then I discussed about what is the maximum current and minimum current. I given what is the current excursion expression, and what is the in type A chopper. Then ripple currents are maximum at a duty cycle of 0.5. What is that maximum value of ripple current? What is the per unit ripple current? How to analyze that is continuous mode and discontinuous mode. Then which region is chopper operation, which region is chopper is not operated. Then I discussed about what is the that is average series current, what is the condition for maximum value of average series current, what is that maximum average series current. Similarly, I discussed about what is the RMS value of freewheeling diode current, what is the condition for maximum RMS freewheeling diode current, what is that value of maximum freewheeling RMS maximum freewheeling diode current. Then what is the Fourier analysis of type A chopper. These are the different concepts I discussed in the type A chopper. Okay, then the final conclusion, I want to write one or two summary points. With that, type A chopper will be completed. Okay, let's write as a note. We know that freewheeling diode current waveform is which waveform? Trapezoidal, that I already given in the characteristics. One is freewheeling diode current is which waveform? Trapezoidal waveform. It is a trapezoidal waveform. Okay. For example, if the chopper is operated in discontinuous mode, if type A chopper is operated in, if type A chopper, this is RLE load. I'm talking about RLE load. Operated in discontinuous mode, then how to write the formula in discontinuous mode, that you concentrate. Let us take discontinuous mode means before completing one time period current falls to 0. If the chopper is on, inductor storing the energy. Chopper is off, freewheeling diode is conducting. Before completing one time period, current falls to 0. Chopper is off. Here freewheeling diode is conducting. Again, this is time period. Okay, this is which waveform? This is I naught, output current waveform. If the chopper is on and freewheeling diode is on, chopper is off means freewheeling diode is conducting. Redraw this. Chopper is on, the freewheeling diode is on. This chopper, freewheeling diode, before completing one time period. Then if you draw the V0 waveform, let it is RLE load. If it is RLE load, if you draw the V0 waveform, if the chopper is on state, that you seen, V0 equal to Vs. Chopper is on means freewheeling diode is off. You see in the waveform, in the circuit, this is RLE load now. Chopper is on. What is V0 equal to Vs? This V0 is Vs. This V0 equal to Vs. If the chopper is off, freewheeling diode is conducting, what is V0? 0. V0 equal to 0. But before completing one time period, chopper is off, freewheeling diode is also off. Still one time period is exist. Some time is exist. In that time, chopper is off, Freewheeling diode is also. Then what is the voltage in the load? The voltage in the load is E. No device is conducting. This is which voltage? This is how much? Vs. This is 0. Then what this voltage is E. But if the diode is also conducting, there exists a battery voltage. But freewheeling diode is conducting, load is short circuited. That's why we take output voltage equal to 0. Let this time equal to TR time because current is rising. This time equal to TF time. Let this is time equal falling, and this time equal T0 time. No device is conducting. Now can you tell what is the average output voltage in discontinuous mode? What is the average output voltage in discontinuous mode? You tell me what is the average output voltage in discontinuous mode. Then the average output voltage equal to, how to write the formula? Vs into TR. Vs into TR plus TF into 0. Because freewheeling diode is conducting, load is short circuited. If no device is conducting, still output voltage is equal to E. That is E into T0 by total time is TR plus TF plus T0. Then what is the average output voltage? Vs into TR plus E into T0 by TR plus TF plus T0. Like this we can write the formula in discontinuous mode if it is a RL load. Okay. This one more observation I want to write. One more observation. Let you take a continuous mode, continuous mode, continuous mode, and you take discontinuous mode, discontinuous mode. Generally I am explaining. In general it is mentioned any chopper. Okay, discontinuous mode. In a continuous mode and discontinuous mode, source voltage. What about source voltage? If any chopper, generally chopper is given. In general, source voltage always discontinuous. It is also discontinuous. Because if the chopper is on, source is connected. If the chopper is off, source is disconnected. Understood? Generally. That's why here it is source now. If the chopper is on, source is connected. If the chopper is off, disconnected. That's why, sorry. Source voltage is always continuous. Source voltage. Because if chopper may be on or chopper is off, chopper is on, chopper is off means we are not switch on the supply. We are not switch off the supply. Supply is always present. That's why always input voltage is constant. Because we are operating for DC na. That's why it may be continuous mode or discontinuous mode. Source voltage is always constant. Source voltage is always continuous. Point to remember. Because we are not switch off the supply. Always supply is connected. That's why DC voltage is constant. Next. What about the source current? What about the source current? Yeah, this is correct. If the switch is connected, then only source current is flowing. If the switch is disconnected, there is no source current. It may be continuous or discontinuous. Always source current is discontinuous. Then what about the load voltage? Load voltage is, what is the purpose of using the chopper? The purpose of using the chopper is to get the variable voltage. That's the reason why always load voltage is discontinuous. It may be continuous mode or discontinuous mode. Always load voltage is discontinuous. Then what about the load current? Based on the load current only we can say that it is a continuous mode and discontinuous mode now. If the load current is constant, it is a continuous mode. If the load current is discontinuous, then it is a discontinuous mode. That's why if it is a load current is continuous mode, continuous, discontinuous mode, discontinuous. These points you remember. For theory questions, this is important. In general, chopper is asked. Like this you can answer. In general, chopper. But point to remember, in step-up chopper or in step-up chopper or boost regulator. In step-up chopper or boost regulator. Always source current is continuous. Source current is continuous. Source current is continuous. Source current is continuous in both continuous mode and discontinuous mode. Discontinuous mode. Because you know step up chopper means this is step up chopper, na? Source is connected like this. If the chopper is on or chopper is off, always source is connected. That's why current is continuous. Source current is continuous. I'm talking about source current. But load voltage is always constant, no doubt at all. Why? Because we are giving a constant DC voltage. But when the source current is flowing, when the source current is not flowing, that depends on the configuration. But in general, in the case of step up chopper, because in source is at switch is at middle, if the chopper is on or chopper is off, always source is connected, source current is flowing. But that is not the case in the case of remaining choppers. Understood that point? If it is not mentioned, especially it is not mentioned, it is a boost regulator or step up chopper is not mentioned, then you take like this. Always source voltage is continuous. Always source current and load voltage is discontinuous. But load current is continuous or discontinuous, that depends on the mode of operation. Easy to remember. This you remember as a special case. Always source voltage is continuous. Source current and load voltage is discontinuous. Source current and load voltage is discontinuous. But load current is continuous or discontinuous, that depends on the mode of operation. Okay. This about in detail about what exactly type A chopper, steady state analysis of type A chopper. Okay. Now based on this quadrant operation of choppers, then you solve some classroom workbook questions, then you go for another concept in the choppers. Okay. Thank you. In the next session we will continue.